Hello and welcome back to Calculus 1. We are talking about mean value theorem. Not mean as evil, mean as the kind of average, you know. So what do we have? Well, let's first understand the concept, then we are going to define a concept, do additional problem, and call it a night. So this is the standard situation. I did this way too many times, these drawings and stuff. So what we have over here is a highway, it's a road, right? Here's a car. We have tires over here poking out a little bit to make it look like a car. There we go. The car is going this way. We're going to put some shrubbery. Put shrubbery, right? So like a landscaping, you know, along the highway. And then, yes,
a rectangle.
A rectangle with tires, and we'll put more colors on this particular rectangle here.
I think it's a very mean rectangle.
And then we'll put another rectangle right here. Yeah, guys, please relax. You should always be... Don't you feel safe and protected?
This is if you guys press the Chester, this solid or not? Yeah, this one.
Alright, great. So now we have two speed traps that are going this way, but... Oh, hold on. First, we'll put a speed limit over here we'll put the speed limit here at 65, obviously. And we can do 55, we can do anything. All right, so here we go. You invested $400 into one of those radar detectors. So you detected both of the traps, right? So you're going to the first one, the timestamp, let's say 1:05 p.m. And because your radar detector went off, you drove through at 65 miles per hour exactly. You were not pulled over. That's all good. Now, about 5 miles down the road, another speed trap was there. Your radar detector went off, right? You went through this speed trap at 109 at 65 miles per hour, and you were not pulled over or anything because as you went through the speed trap, you went at 65. So that's all good, right? Few days later, the ticket for speeding was mailed into the, was mailed to you. Now, I already heard that's the worst, which means it already happened, and the person self-identified. So, is it happening? Yeah. Wait, hold on. Speed limit 65 went through both traps going 65. No one pulled me over. No one asked me anything. Got the ticket in the mail. What the hell? Right? Exactly. Calculus. Mr. Newton, what did you do to us? Well, let's consider what we have. First off, we do know that velocity is distance over time, and that's the average one, right? That's the slope of the secant line. We know that from chapter 3. Now, what's my distance? 5 miles, right? What's my time? 4 minutes. So what's my actual time? I have 4 minutes. I need to cancel minutes, so 1 hour has 60 minutes. Minutes and minutes will cancel, so now it's in miles per hour. That's great. So I have 5 times 60 divided by 4 miles per hour. This will cancel to 12. No, sorry, 15, thank you. I was calculating and I saw something wrong. And then 5 times 15 is 75 miles per hour. It's exactly what your ticket has. Whew. Spicy, huh? Now, can you get ticketed for average? No. You only get ticketed for instantaneous. But both instantaneous speeds were 65. So why are you receiving a ticket on 75, which is average? Well, you're receiving it because of the mean value theorem. Mean value theorem states that if the function is continuous and differentiable on the interval, there is at least one instance where the average speed and instantaneous speed is the same. So whatever your average works to be, it guarantees that the instantaneous speed will be that at least once. Now, you can't teleport yet, so it's continuous, right? And the whole road is differentiable, meaning it's smooth, right? You have the velocity you're driving, right? So we have differentiability because you have velocity in your car, right? And you also have that the road is continuous, your trip is continuous, there will no teleportation at any point, no vertical asymptotes, nothing. So conditions for the mean value theorem are satisfied, and because the conditions are satisfied and the mean value theorem states that at least once, if the conditions are satisfied, at least once your instantaneous speed is the same as the average. Once you calculate the average, that means that at least once you were driving 75. Now, common sense would say that you were driving also higher than 75, because if your average is 75 and your start point and end point about 65, common sense would say that you had to go way over 75 for a period of time right? But that can't be, right? Those numbers cannot be proven by the theorem, right? So you will get the ticket for the 75, which is the average. And we know that at least twice you went, because think about it. If your velocity graph is 65, 75, 85, whatever, right? That's the velocity. If your starting time, and you go like that, and your end time, so this is your 105 p.m., because this is the time axis, and this is your 109 p.m. Here is your average, and you see that your instantaneous speed matched at least twice, because in order for 75 to be average, you have to go more than 75, and then you have to go back through 75 to go to 65 through the second trap, right? So you went 75 at least twice. Also, we know that you went faster than this in this period of time. So how does this work? Easy pass. Yeah. Uh-huh. Wait, what? You have the gates that are separated exactly with the... So timestamp simply tells you these numbers. What? You're surprised now?
That wouldn't happen because two different top planes.
No, you just need 2 easy pass gates and then you fix it, right? Because the cops would actually have to keep the track of which car passed by, what's the license plate, what's the color, what's the... right? So you say, okay, the red car passed by, it's 105, the other one is waiting, okay, 109, right? No. Easy Pass has the license plate and registration, everything scheduled. You just pass through one ramp, right? So even if there's no cops on the road, you pass through the first Easy Pass gate at whatever, 35 to read it or whatever. Then you drive 150 miles per hour. You get before the second gate, then you park and you wait until the time ticks. And you pass through the second, no ticket, right? No ticket because you waited. See, you can't cheat on time. Right? People speed because they think they're going to get somewhere faster. Right? Which is kind of silly because on short distances you save 20, 30 seconds risking $400 ticket on a short distance. So you can do these calculations on your own. It's completely pointless to speed unless you are driving for 3 hours. Then you are saving 15 minutes, and I think that's even what you can do in 15 minutes, nothing. So speeding, excessive speeding, unless it's for thrill, is completely not warranted. Because you are not going to gain on time. You're not going to gain on time at all in any of those situations. Anyway, so now we are going to write the theorem, do another example from the textbook, and call it a night. So here is the theorem. So if f is continuous, on closed interval a, b, which means including the endpoints, and differentiable on open interval a, b, then there is at least one point C in AB such that the derivative at C is equal to f of b minus f of a divided by b minus a. Guys, this simply says m tangent is the same as m secant. The instantaneous equals the average in at least one point. Could be more, but at least once. So we are able to actually find this value c if we have the function and we have the a and b values. We can compute c. So let's see one of those calculations. Maybe we can do two examples. So mean value theorem, say problem 26. Oh, by the way, when you are looking in your textbook, and I had issues with some students, and you see this symbol, that means use technology to solve it. That means probably equation is not working out, or so if you are working homework examples or examples on MyMATLAB, you run into this symbol, it's a blue T, that means use technology to solve equations. So Wolfram Alpha or Mathematica or calculator, some of that stuff has to be used. Those are the problems 27 and 28. I want to work on 26, which is going to say f of x is equal to ln x, and we are on interval 1 to e. We are looking for value c at which we are going to have instantaneous be the same as average. So now we know if you just need to plug stuff into the formula. What do you have on the left hand side? Derivative with c plugged in. What's the derivative of ln x? 1 over x. So what's f prime of c then? 1 over c, because you replaced x with c. Great. So now, what do I have? I have 1 over c is equal to function computed at b, that's ln e, minus function computed at 1, because that's a, divided by b minus a, which is e minus 1. This is how simple it is. Find the derivative, replace the x with c, and you have your left-hand side, and then use the function and a and b. So now I have 1 over c is equal to 1 minus 0 over e minus 1, which is just 1 over c is equal to 1 over e minus 1. And now the best trick in the galaxy, because we have fractions, if you flip left-hand side, you flip the right-hand side, so c is equal to e minus 1. And you can cross-multiply, whatever. There you go. That's the value. It's about 1.7. At about 1.7, instantaneous and average values are the same. So that is what mean value theorem guarantees. How about we take a look at one of the word problems, because we can do that as well. Ooh, drag racer acceleration. I think this is the new problem. I haven't seen this one before. So this is problem 20. Fastest drag racers can reach a speed of 330 miles per hour over a quarter-mile strip in 4.45 seconds from standing start. Complete the following sentence about such a drag racer. At some point during the race, the maximum acceleration of the drag racer was at least, and then they say miles per hour per second. Great. At some point in race. So what do I know for this drag racer? I know that they said that the fastest drag racer can reach a speed of 330 miles per hour. So 330 miles per hour over a quarter-mile strip. So distance is equal to 1/4 mile, quarter of a mile. And the time for that is 4.45 seconds. That's it. So what do I need here? They're asking us to find the maximum acceleration. What's acceleration? Speed over time. No, just time. So this piece of information is not needed, actually. Right? Yeah. It's a quarter mile. So what do I have? I have that acceleration average is going to be the 330 miles per hour divided by 4.45 seconds. Now look at the units that are asking for. They say at some point during the race the maximum acceleration of the drag racer was at least blank. Right? They give you blank to write the number, and they say miles per hour per second. I don't even have to convert this. I just need to divide 330 by 4.45. I'm done. So what do we get? Because you already divided this. And you wonder why I drink. 74.15 miles per hour per second. There we go. And now by mean value theorem, we know that instantaneous acceleration was this much. So A instantaneous is 74.15 miles per hour per second. All given. Very simple, right? Why, disappointed? I'm sorry, but that's it. Bye.